demo service, gives us the ID with payload length, and gives us the payload length. It's actually a length there. And then we have, we're going to make a message by formatting this like message string and export it into our distributed availability store. And then we're going to encode and output the place in our availability store that is sitting, the payload itself, straight, and the output from the authorization itself. I'm just going to encode that and output it into accumulate. We look at accumulate. What's it doing? Well, it's printing a debug message, and then it's going through all the refines that it's getting, which is actually probably just going to be one of them. And then it is decoding the refine output, so it's extracting this ID, payload, and auth output, and it's just sticking them in the state of the service. Yeah, this highly coherent state. For the ID, you are formatting it as a string rather than putting it sort of directly as a I'm not going to go into I'll transfer it. I compiled this earlier by running JAM PVM build. I'm going to do it now. It takes a few seconds, and I want to get off JAM. Okay, so we have a REPL. Yeah, REPL is a command line interface for using JAM. What this does internally is it sets up a small JAM testnet sitting behind it, and it doesn't just author blocks all the time like it would do normally. It only authors blocks as we tell it to author a block, or as we need a block being authored. We have this instant extend, which means just author a block as it's needed. So we have, if we look at the services, which we can find by ls, then we can see there is just one service called the Bootstrap service. This is a general sort of Swiss Army knife for functionality. It allows us to do things like create other services, transfer funds, alter what's the authorizing page that the authorizers our authorization queue, and lots more. Basically gives us super user access, administrative access to the JAM machine. We also have the concept of a default service, which is the service in ID that it uses if you don't specify a service. This is sort of like at the current directory, so to speak, at the JAM term. Right, so let's start by creating a service. Assign, just create service. I already compiled the PVM, the demo service, this code over here. We have a look in our directory, we'll see demo-service.pvm. So let's create that. To do so, we have to hash the data at demo-service.pvm. It understands that I got the data for the hash from demo-service.pvm, and so we'll feed that into the service automatically as its data. Basically, it does a lot of stuff that we would normally, as far as JAM is concerned, is like individual steps. It sort of amalgamates them together as much as it can, so that I don't have to do too much faffing around. We need to give it a bit of balance, so we can store some data in its storage, because we know that that's what the service is going to do. For any data that you store, you have to have some sort of balance in there, like a minimum balance. So if you're familiar with Polkadot, it's like the existential deposit. Don't think we need that much, I'll put 1,000. And there we go. So looks like it's worked. It's telling us our default service is now A. This is services actually have these kind of long numbers in here, 32-bit, 32-bit identifiers. But typing in a 32-bit identifier is the thing, so the CLI gives us just methods to use. If we list the services available, we see there's now 2 services, and for what it's worth, I can CD back into 0, and then it's 0, CD A. Good, so how do we do something with a service? Let's make a work item. A work item is like a sort of transaction for a service. It doesn't necessarily have any sort of signature, it's just general data. What would be the signature is actually the authorizer, right? And you might be wondering, hold on, what's the authorizer? I'll go into that in a second. For now, you just need to know it's looked after, it's taken care of. So we're going to make a work item. We start by saying work item, and then we'll have a work. We'll just give it hello world. Hello world. Better than that. Oh, good. Now it's telling us, all right, you've made one work item. It's pending. Now we want to package that up into a work package, one of these 6-second, whatever, parcels of execution, and give it over to the chain, get it guaranteed, and into the system. So we say that's, we use the term guaranteed for this. What it's just going to do is take this work item, parcel it up, and feed it through the system. And there we go. We can see now it's we get similar debug messages actually to when we created the service in the first place. You remember the service, creation of a service actually needed a work item to be created. We didn't specify it explicitly. We let the CLI do that for us, but that's actually what's happening behind the scenes. And yeah, it looks as though it's been guaranteed. We don't know for we know that the two debug messages are printed. One is in the refine, and it says that the payload length is for 13. That looks about the right size. And then we got one item into accumulate, so that looks quite good. So what are we expecting? Well, if we go back to our code, we're expecting firstly something to be in the distributed availability system. We're expecting this message from the refine logic. And then secondly, we're expecting a bunch of storage items to be written into the state of the service, one of which, this last info ID, will help us find this data that we put in the DA system. But first, let's start with the others. So last payload. This is going to be the, should be the payload itself. To read read the storage, and then we just tell it we want to know the last payload item in the service. It's actually going to use the default service, which is A. I could specify A specifically. I'm not going to bother, and then it will say it's okay as we were expecting. So that means that yes, refine has passed this message into accumulate. Accumulate is correctly written into storage, as we would expect. Now we can also read storage. One of the other couple of things. Let's read storage of the last info ID. This is going to tell us where in the DA we have its place. It's actually only going to tell us the index in the work package. We know the work package hash because it's written here, and then it's going to tell us the index within that work package. So we'll look, and it says 0. Surprisingly, you only are at 1, so it's got 0 index. So let's see if we can read that from the DA, read segment. For reading a segment, we have to tell it the work package or the segment root. This is a cryptographic commitment. In our case, we only need to specify the first byte, and it knows what the work packages that have been authored are, so it's going to fill in the rest for us. And then we need this 0 first item. That, and then yes, it's telling us that there's actually one segment in this whole thing. That's a segment tree root, since that's the cryptographic commitment for this. And this is the message sort of in the segment. It says payload is okay, as we expect. The authorization output is authorization equals nothing, as we will expect when we see what the authorizer is. And then we're also telling us we've got 4,000 equal zeros on the end because this is a 4K segment, and we have to fill it with something. So in this case, it's zeros. Authorization is the empty string. Why? Well, authorization output is authorization equals the empty string. Where is that coming from? Let's have a look at our authorizer. So this is what an authorizer looks like. It's similar to a service, but it only has one function. Function is authorized. This is the single entry point of an authorizer. It gets given the parameter. You remember I said authorization codes can be parameterized. Authorizing agents can be parameterized. And then it's also giving us the work package, which is the bunch, the whole thing, right? all of the work, all the description of the work that needs to be done. Yeah, it's telling us the core index as well. So it's going to print an information statement, and if you remember, we did get this information statement, null authorizer, lots of information there. It's going to check to make sure that the authorization data is the same as the parameterization data. What does this mean? Well, it means we parameterize this code with para. That's fixed at the point that we are specifying what is allowed to run on the core. That's fixed by the agent that purchased time on the JAM machine, right? That's the one side of the coin. The authorization, the package authorization, that is not fixed by that agent. That is fixed by whoever built the package. What does this mean? Well, it means you can do things like check for a signature. You might, for example, place the public key as the parameterization. You may even do it as your own public key. And then at some later stage, in the authorization, when you're ready to actually build the work package, then you've got a signature, you sign the contents of the work package. And then the authorizing code will just check that the signature, or the public key coming from the signature, that we verify the signature is having, is the same public key that the code was originally parameterized. Yeah. That would be one way that you use this, but there are lots of other ways. You could, for example, have a ZK commitment, and you could say, right, there must be a zero-knowledge proof in the authorization data that proves that it was one of these validators, or that some particular piece of computation was done correctly inside of the work. And it's actually that we're checking in the authorization. There are all sorts of things that you could do. But basically, you get free reign over passing data in as the purchaser of the gas and proving yourself as the author, builder of the work package. In this case, we're just checking that the builder of the work package has put the right token in. We're just matching the token up to whatever the person who purchased the gas for the work package. And then we are making a message, authorization equals something, and then we'll pass it equals the package authorization. Right? We're just passing that out. So that's actually where we get the authorization equals empty string from. Why is it the empty string? Well, it just turns out that the default authorization doesn't have a parameter. It's just empty. Yeah. But what we can do is we can have a play around with this and make a new authorization with like a special password. So in this case, we're going to push this is a CLI thing. We're going to push an authorization into our list of known authorizations. CLI is the thing that's actually building these work packages. It needs to know what authorization to put in the work package. We're going to push a new one in so it can choose this if it thinks it's necessary. We're going to start with just saying, well, we're going to use the null authorization code still. That's this code here. But we're going to pass in some sort of token, like some parameterization. We'll make our parameter, just make it type A. And then we can specify what we're going to use as our default work package authorization. Now, if we set anything other than type A here, this is a useless authorization because it will go into the authorizer and then fail. Because it's going to check that they're the same, right? So let's make it work. We'll put type A in there as well. Okay, so now we can list the number of which authorizations we have by doing that, and we see that there are now two authorizations. There's our original default one, which just has the null authorizing the empty strings, and then we have a new one, B, which is the one with typing. Now, we will. Now, what we need to do. This is all very well. It's not going to use this second authorization because the cause. If we look at the authorization of the cause, which we can do very easily by inspecting the pool of core 0, our authorization pool for core 0 is this 0x73 hash, which you'll see is the same as A, authorizer A. Okay. That's why this all works. I can actually have any work package in at all, because the authorization pool matches the authorizer that we're using. Now, if we if instead what we do is we assign to the pool, assign to core 0 another authorization, B. It says assign, and actually it needs 80 of these things, so it's going to just replicate within 80 times. So if we now look at our pool, inspect our pool for 0, oh, it hasn't changed. No, it hasn't, but if we inspect the queue for 0, now that has changed. That's now 0x29. If we extend the block, the chain, and have another look at our pool, we see that we're starting to fill up with a new authorization. And the more that we extend, let's just extend it 5 times. Now we only have the new authorization, 0x29. This means that the pool is unusable, or it can only be used with that new authorization. If we delete that authorization, it won't be used at all. Now what we're going to do, go back to our list of authorizations and remove the first one, RA. Remove auth A. And we only have now one, it's this new one, 0x29. That's fine, because it's our pool is now full of these things, so we have lots of tickets for our authorization too. Good, so let's do the same thing. Let's make a work item. Work item, let's say, hello. And guarantee that. We actually have some shortcuts. G is shortcut for guarantee. Guarantee it. Now, hopefully, this will do something. There we go, it is. So it's coming to the null authorizer as we want, and it's showing us that the parameters is now parameterized with the password. Okay, and but it's okay. Our token, our authorization token, is also now made equal, so it's going to go through okay. And then we have we go into the refine, and we have a new payload. And blah, blah, blah. So let's have a quick look, make sure that it has actually changed our storage. Last payload, and indeed it has. That's nice, and it should also have changed. Now if we look at the last auth ID, last auth, what was it? Auth panel. Last info, wasn't it? Last info ID. Yeah, 0. So that means that if we look at the segment root of this work package, so we read segment 0xf, 0, then indeed we now have our new authorization output, auth. Okay, into the empty string that we had before. Finally, I think we can read the story of last auth output. Good. And for what it's worth, if we change our authorization, so we do push auth, we're going to make this the wrong city. Maybe we get confused and we set. And then it's yes. So let's clear the authorizations. And then add this new auth, and then remove the default auth. Okay, now we have a broken authorization, right? Because our parameter type A is different to our authorization token type 1. This is a bit like if someone tries to use the wrong signature in our example. So use this information. Now, if we try to create a work item, hello. It's pending. Okay, fine. Try to guarantee it. the same thing, but we'll add just a null authorized authorization. And then we'll remove our other one. Actually, let's do a okay. So good. I think that demonstrates everything that I was going to demonstrate. So yeah, there you go. That's JAM doing its thing.
Perfect. Thank you so much, Gavin. Let's give him a big round of applause.